Hello and welcome back to our seal integrity testing video, more specifically the dry vacuum leak test part 2. And in this video we will go ahead and present some real life testing examples where we'll go ahead and test some pouches, some sachets, and some heat sealed bags and talk about what's happening. So real quick guys, we are Senatron and we are an engineering excellence company. We are located in Salt Lake City, Utah. We have been in business since 2008 as peak-to-peak engineering and since 2013 as Senatron. So our three main focus areas where we are experts in is vacuum science and technology, custom fabrication, and more specifically polymer fabrication. And we also are experts in robustly designed and quality engineered systems. So we mainly develop, design, and manufacture vacuum systems, and this includes laboratory equipment, leak testing systems, and instrumentation. And we also make vacuum testing systems, which is why we made this video for you. So our objectives today are: we will simply perform a few dry vacuum tests and show you how good pouches behave under vacuum. We will test sachets, pouches, and bags which are filled with either dry powder or liquid. And we will perform two types of vacuum tests. So the first test, we will pull 15 inches of mercury, which is about half a vacuum. And then a second test where we'll show how pouches behave when we pull a 27-inch of vacuum. And we're talking about gauge vacuum, which is reference to atmosphere. Alright, so here it comes. So we will place several pouches and bags into a 20-inch vacuum chamber, and we will pull a vacuum of 15 inches of mercury. So 15 inches of mercury is generally the best vacuum to test pouches that will be transported by land. So anything that you heat seal and you would like to confirm that your seal integrity is validated and qualified for your heat seals and pouches to be transported by land, you can go ahead and test them at about 15 inches of mercury, which is about half the vacuum. And this is equivalent to about 18,000 feet of altitude, which is 5,500 meters. So in North America, 12,000 feet is about the highest altitude that packages will experience being transported by land, and that's across the Rocky Mountains. So like I said, if your pouches pass being tested at about 15 inches of mercury of vacuum, of course, then you can conclude that your pouches are validated to be, transported safely across North America. Okay, so as you can see, we have a small heat sealed pouch that we have placed inside our large 20-inch acrylic vacuum chamber, and we are slowly pulling a vacuum. And if you look closely, the pouch is expanding. And the reason that is happening is because the air inside the pouch is now greater than the air outside of the pouch due to decrease in air pressure, of course, inside that vacuum chamber. So as you can see, the pouch will swell up, and remember, we're only going to about 15 inches of mercury of vacuum. So that's about, half vacuum, or I'm sorry. So that's about half atmosphere. So that's about 15 inches of mercury of vacuum. And then looking from the top. Okay, now we have opened the venting valve and we are releasing the vacuum and bringing the vacuum chamber to ambient pressure. And as you can see, the pouch will also go back to its previous or initial volume. So we will repeat this with a different pouch, and again we will of course close the lid, and we will close the venting valve, and you will see we will slowly start pulling vacuum on this pouch. And just like with the previous smaller pouch, it will start to expand as the vacuum increases. And the expansion, it seems like it is similar to the first pouch. Alright, so once we reach the desired vacuum level, we will close the vacuum valve, and we will watch the pouch, of course, and then we will release the vacuum again, as you can see here, and the pouch will revert back to its initial form. Okay, so we are testing two different pouches. So these are not see-through pouches. I am not sure if this is Mylan or not, but in any case, it is a heat-sealed film, and we will go ahead and pull vacuum on them, and let's see what happens. So it looks like these pouches will also expand as you pull a vacuum. This means that this is a good seal. It is an airtight seal, because again, the pressure inside is greater than the pressure outside of the pouch. Now it's a little bit tougher to see on these ones, as opposed to the previous two that were see-through, but they are expanding, so we are seeing some expansion here. Which means that these pouches, or these types of pouches, are also a good candidate for vacuum leak testing. And once again, we are releasing the vacuum, and the pouches are reverting back to its initial form. Okay, so we have placed a large food bag into our acrylic vacuum chamber, and we will go ahead and start pulling vacuum. If you watch closely, you can see that the bag is slowly expanding as the vacuum is increasing. It looks like it's gonna tip over. Yeah, so initially when we performed this test, we were a little bit concerned whether or not this bag was going to pop or break. So we were very, very careful as soon as we reached about 15 inches of mercury to close the vacuum valve. And I'm not sure if I mentioned this or not, but we were performing these tests by just looking at our vacuum gauge, and as soon as it reaches 15 we would close the vacuum valve and then release the vacuum. So it looks like this is a pass. So this was a good pouch, and this is a pass. Okay, so we're gonna place two, again, food bags, and we will go ahead and start pulling vacuum on them as well. So we close the venting valve and we open the vacuum valve. And just with the larger bags, we were also concerned whether these pouches would pop or not, but luckily they did not at 15 inches of mercury, so that was a good sign. Once again, they passed at 15, so they're all set to be transported by truck in North America, of course. And then, once again, once we have reached the 15 inches of mercury, we will, right there, we're going to release the vacuum. And they will deflate. Now you notice how they are smaller than they were initially, and we'll talk about that later. So hang on and we'll explain what happened. Okay guys, so what we'll do now is we will go ahead and place these same pouches that we've tested just a minute ago, and we will go ahead and place them into a smaller vacuum chamber and pull 27 inches of mercury of vacuum. So 27 inches of mercury of vacuum is pretty much the best vacuum we can reach or pull here in Salt Lake City, because we are at a higher altitude. We are not on sea level, which means that our ambient vacuum or our ambient air pressure is a little bit less. So 27 is about the best. I mean, in some days it's 28, but generally speaking it's about 27. 27 inches of mercury of vacuum is equivalent to about 54,000 feet, which is 16.5 kilometers of altitude. So if your pouches pass 27 inches of mercury, it is safe to conclude that your pouches are validated to be transported by aircraft. And remember, of course, aircrafts are pressurized to about, I would say, 8,000 feet of altitude equivalent. However, we're talking about your pouches or your packages being resistant to accidental depressurization at higher altitudes. This also means that your heat-sealed products can be airdropped from a higher altitude. Alright, here we go. Okay, so we are performing a test on our smaller 10-inch cube chamber, and you probably notice it's a lot smaller and also beat up because, yeah, this chamber has seen better days. We have used and abused this guy for a long time. And of course, smaller vacuum chambers are better because you can pull your vacuum, your desired vacuum, faster, and you can of course test your specimen much faster. So here we are actually pulling a vacuum, and we're going as low as we can go with regards to absolute pressure. And as you can see, the smaller pouch, of course, the see-through smaller pouch is inflated quite a bit, and we're actually pretty happy because this is a good seal, and you see we're reaching about 25 inches of mercury, so this is kind of nice. So this is a pass. So these bags can be transported by air, and of course we just released it, and it releases the vacuum much faster than the previously one. So let's start with this Mylon bag, I believe. And again, we're going to start pulling vacuum. And as you can see, once again, the rate of change of vacuum is much faster because the chamber is smaller. And just with the previous pouch, with the smaller one, this pouch also is doing really well at higher vacuums. Okay, so let's try this food bag. And again, we pull the vacuum, and this bag expanded quite a bit, and we were not sure if this bag was going to make it or not. But it actually did. It actually did make it. And of course, remember in the previous video, like a minute ago, when the vacuum was released, this bag was actually smaller and almost seemed like it was vacuum sealed. And the reason for that is twofold. There could have been a leak, which is very unlikely, because if you would have seen a leak, this bag would have not expanded this much. And the other reason is that this material, the pouch material, is permeable to air. So when you pull a vacuum, the air inside this pouch escapes slowly, which you cannot see since the vacuum still is lower, or since the pressure inside the pouch is greater than the pressure outside of the pouch. And remember, this is what I was talking about. So it looks like it's vacuum sealed. So this leads us to conclude that this material is permeable. Sometimes it's a good thing, other times it's not. It really depends on your application. But again, this is a good pouch, and if you want to know if it's permeable or not, you have to talk to your film manufacturer. And let's move on to the largest pouch, or I'm sorry, the largest bag. And here we go again. So we are pulling a vacuum, and as you can see, this pouch also expanded quite a bit. And let's see if it's going to pass or not, if this pouch is going to pop, or if this bag is going to pop. I'm sorry. Bag or pouch, what's the difference? I guess one is larger than the other. Well, you guys can tell me. You can just leave a comment below and let me know what the difference is between a bag and a pouch, and at what point does the pouch become a bag? I guess that's more of a philosophical question. All right, so we're pulling a vacuum and we're holding it a little bit, and in a minute we're going to release it. Right here, it's released, and again, it actually became a little bit smaller, so it almost looks like there is some air that escaped, but it was clear that this was a good bag as well. It passed, and so we're going to give it a thumbs up here. All right, well, let's move on to the next slide. Okay, so, and then one last test that we'll perform is we'll go ahead and place several sachets that are filled with liquid, more specifically oil, and we will pull a vacuum. And what will happen is that the sachets will inflate, as you've seen with the previous pouches and bags that inflated during vacuum. However, sachets that are filled with liquid are generally easier to inspect for, and that is because if there is a failure, you can of course see the oil essentially being expulsed onto the vacuum chamber. So here we go, guys. Let's take a look what happens. Okay, so we have placed about a dozen of these sachets into our 10-inch acrylic vacuum chamber, and we are pulling a vacuum as we speak. And just with the previous pouches and bags, these sachets will also expand as the vacuum inside the chamber increases. But pay close attention, because some of these sachets are sealed on all four walls, while other of these sachets are simply sealed on three walls, where you take a longer film and you fold it over and then you just seal it on three walls. So this was actually the test we wanted to perform to confirm that the 4 seal and the 3 seal will pass at a higher altitude, or of course as we pull the vacuum. that there will be no failures. And it turns out that they all passed. So this is also a pass. Well, this concludes our video on how to perform a dry vacuum leak test on your heat sealed pouches, sachets, bags, or anything that is heat sealed. So please don't forget to subscribe and like this video. And if you have any questions for us, feel free to either post down in a comment below, or you of course contact us through our website. If this video receives a lot of questions or enough questions from you guys, we'll go ahead and make a part 3 of this series. And I kind of have an idea what part 3 will be. My gut feeling tells me you guys want to see some failures and explosions, and pouches just failing inside the vacuum chamber, and it seems like that's a lot more fun than these boring passing quality products. All right, once again, thank you guys very much, and you have a wonderful day. Bye.